George Fahmy, the founder and CEO of Stakpak. When I'm not trying to create like cartoon versions of myself, I'm really into developer experience and security, which are usually two things that don't mix well. And we're building an open source agent for DevOps. So we're trying to solve this problem because like people, as they realize on X, that like LLMs are the worst at the worst part, at least like coding, of the coding, which is actually setup and deployments. And yeah, a year later, this guy like literally gave up and said, okay, it's AGI when LLMs can do DevOps and can configure my pipelines and deploy in a cloud provider. So we set up to try fix this. There are theoretical reasons why this happens. I mean, I'm sure you tried it out if you're using agents, like who's using Claude Code or agents in general? Who tried using agents to do DevOps work? Yeah, which is a big umbrella of things. Okay, so one of the reasons is like LLMs, they suck at domain-specific languages and specifically knowledge that's fresh. And in DevOps infrastructure, you have both. You have a lot of domain-specific languages and YAML schemas, but you also have knowledge that changes frequently. That's one of the reasons they're bad at this. So that's why we built Stakpak, which is an open source agent in Rust that's trying to solve this. And it started doing that. So like the past 2 weeks, there are 100 developers that tried doing different things with the agent and they were successful, like containerization of specific stacks, almost reached 100% success rate. But like all this doesn't matter if something like that happens. So here I'm not singling out Replit. This happened with Amazon Q, almost happened with Amazon Q and GitHub Copilot. And it happens with all of you, like how many times have Cursor deleted something or like deleted your file system or like did something funny. So this happens and this kills the trust we put in agents. So if we're trying to make infrastructure self-driving like we're trying to do at Stakpak, this just kills the trust. It's not possible. So while we're trying to make agents accurate and better at infrastructure, we found this bigger problem that needs solving. And that's what we're going to talk about today. So if you stick around, you'd see me leaking our production secrets on YouTube and nuking our production infrastructure. So hang on till the end, because it's going to be interesting. Yeah, that's your reward for attending this talk. So to start off this, I imagine like you use agent, you know at least a little bit how agents work. So here we're going to build a very simple threat model. And threat model is basically you trying to figure out everything that can go wrong and then try to design your way around it or like prevent it from going wrong. So this is a very simple threat model. Here you'd see like there are components of building an agent. There's an agent client or an MCP client if you're using MCP, which is the part that takes user input and calls an LLM. And there's also the tools, which can be an MCP set of MCP servers or it can be built in the agent, depending on which agent you're using. But like this general is the same. And this is the security context. Security context in threat models are usually like a physical machine or like an imaginary boundary of things that have like high trust between each other. So the agent trusts its own tools. Assumption, like it's an assumption. And then the tools interact with the local or remote device file system if it's a remote server over SSH or SFTP, or if it's a local machine if you're working with it locally. And then through the network, an MCP tools can go like through the stack or system calls. They can make external API calls to the cloud and try do weird stuff like try provision, destroy, or like manage cloud infrastructure or an external API. So here we're going to share our experience and the research of some of the stuff we did on securing agents, making them like guided so they won't destroy stuff. Your database, for example, but this applies if you're also building agents that interact with APIs in general. So you might find a little bit of this talk useful. So the first threat we're actually going to talk about is leaking sensitive data to the LLM provider. We're not going to talk much about like leaking stuff through LLM tools because in our case, this was the main concern because we were building the tools, at least most of the tools the people need. But like you would also be worried about leaking secrets to the LLM provider. Another threat is trying to break production systems, so breaking configurations on a live server or your local machine and bricking the machine, for example. This is another threat. A third threat is trying to modify cloud resources, which is the most juicy part, as you will see in the talk, like trying to destroy a bucket, delete a database, and so on. You see here I'm highlighting the red lines because usually when you're crossing, like the data flow is crossing a security boundary, this is where most of the interesting, weird, and scary stuff happens. There's also injection, but we're not going to talk about injection, mainly because a lot of people already like looked into injection and what to do about it, and because it is a vector to other threats. So injection in by itself is not scary, but the things the agent can do when it's injected is the scary stuff. It can leak data, it can break configurations, it can modify resources in an attended way. So we're going to take each of these three threats, and we're going to talk about the design space, what we considered and why it doesn't work, some of the stuff we considered, and the actual implementations we settle on. Some of the times it's not perfect, but sometimes we're very happy with it. But that's the goal of this talk, like to spark this discussion. Okay, so the first one thing about leaking sensitive data. What's the most obvious thing to do? Not leave secrets in plain text, right? Very obvious, but like we can do that. Like we still use .env files. We still somehow need to generate these secrets to set them in the first place. And if you want your agent to run your infrastructure autonomously, it will have to generate secrets and actually use them. So this doesn't work. Like if it had worked, we wouldn't have any of these issues, or like no OpenAI API keys on GitHub. A second solution would be to redact secrets. Who thinks this is a good idea? Please raise your hand. Okay, so at first it seems like a good idea, but if you want your agent to actually work with the secrets, like compare secrets to debug stuff, it wouldn't work because the secrets are all redacted. Like how would the agent be able to reason about the secrets, set them, and compare them to debug stuff if it's all redacted? A third solution, which is like the most obvious one and the most like popular one, is to ask the LLM nicely to handle the secret properly. And yeah, you know how that ends, so let's not get there. So what we decided to do is to use secret substitution. So we detect the secrets. So what we did here is we took the Git leaks public rule set, and then we implemented that in Rust because we wanted it to be implemented in the agent. We didn't want to have a lot of third-party dependencies. And it's actually open source. It's Apache 2.0. And what it does is between the agent and its tools, which is the hands. So the agent is the brain. It thinks about stuff, and it takes actions with the tools. And between the tools and the agent, we inserted this secret substitution layer, which is like this ether sort of weird laser boundary that turns the secret into a unique ID, and then shows this ID or placeholder to the agent. The agent works with the unique placeholder, and then writes it back. And whenever it's written back, it would substitute it back. So yeah, a demo is worth 1,000 words, so let me show you. So here, I started a Stakpak instance on our live production, connected to our live production environment. Whoa. So I asked it like what permissions do I have in AWS. And you can see this is not a secret per se, but it started already redacting things, like the account ID. Here I'm running in privacy mode. That's why it's redacting account IDs and public IPs, but these are not secrets. But yeah, so you can see like how it looks that when it's actually like being parsed by the LLM. Remember this, like I now have administrative access to my AWS account. This is important for later on. And then I can ask it to list my EC2s. And because privacy mode is on, the public IPs should be hidden. And yeah, I can ask it to do something like dump the IAC eval public IP to a file. Sorry? Yeah, sure. So it dumped the stuff in a file. You can see how the LLM sees things. But like if we go here and we try to look at it, you see the actual IP, because this is like the weird layer we talked about, like it translates the secrets into IPs and so on. And it remembers the stuff. And this is like, for the moment, it's stored in a local file system. This is all open source. You can check it out. But in the future, it can integrate with other secret managers. So future work here, we are refactoring this into a local MCP proxy. So you can have this secret substitution with any third-party MCP servers you can use, not just like the tools we built Stakpak initially. But there's also something very interesting. There's a project on GitHub called FuzzForge that compared using LLMs with rules like deterministic static analysis tools like GitLeaks and TruffleHog to do this. And LLMs are actually much better at detecting more secrets. But then like the first glance, like you think this is stupid, like we're trying to prevent LLMs from seeing the secret based on our threat model. But like again, take this further. Like what if we can take this and build a small language model or fine-tune a small language model that can run locally on your machine to augment these tools? Because according to this, LLMs are much better at detecting like well-hidden secret or like dynamically constructed secrets than GitLeaks. And GitLeaks has like, yeah, there are some caveats to the rules. They don't always work. So this would be perfect. So this is something we're going to explore in the future, is building smaller language models that can augment these static analysis tools to figure out like harder to find secrets and redact them before they go to the LLMs on the cloud. So the second threat, breaking configuration files. So the first solution is to codify everything, like turn everything into infrastructure as code. And there's a reason there are like 5 or 6 companies trying to help people codify infrastructure. Like companies are never done codifying the infrastructure. And there's always like an escape hatch where you do stuff manually. So this doesn't always work. Like this works in a perfect world, but like in reality, it's very hard. Second thing is to back up everything, which also works in like in theoretically, but in practice, yeah, there's a reason why ransomwares are still like a threat is we don't all back up things. Another one is file system overlays. This is a perfect way to do this, where you see a truth like change and look like edit stuff on an overlay and then persist them later on, so you can like revert these changes, but requires root access. So this is the perfect solution for this problem, at least from our perspective, but we're still investigating this. So we didn't end up like implementing this as the current solution. What we did is we built recoverable file system operations, which is not perfect. I mean, the LLM can still like decide not to obey you, like the data GIF I showed you earlier. And it feels trivial initially, but like there's some nuances here. So for create, it's very easy. Like you can just delete the file you created by exploring the history, like looking to the LLM history. But string replace, you would think is trivial, just like reverse the operations, but it's not. Like this is an example, like this like 4 or 5 line Python code. If you're trying to replace hello with hey here, it would replace it correctly, but if you're trying to reverse the operands, it wouldn't work. And this is one example of a lot of examples. So this, like, if I can, yeah, this would output false. And there are a lot of examples where this doesn't work. So the way we got around this is the string replace to output is actually a UDIF of the operation. So then it's perfectly reversible because it includes context on where the stuff changed. So you can actually reverse it. And the same thing with backups. By removing files, we added a remove tool. I know the LLM doesn't necessarily have to respect that, but yeah. That backups remote files when the editing operation is done on a remote system and backs them locally if we're working on a local system, because people use Stakpak over SSH a lot. And you can see here, so remove the file you created. It also works for directories recursively. So I called the remote tool, and in the context, it returns like the tool result, it returns the backup location. So here, if I list it, there's nothing, and then store it. I know you don't have to use an LLM to restore it, but like, yeah. Now you can see the file is back. This works for directories as well. It's basically like re-implementing trash again in the terminal. Yeah, so for future work, we want to revisit overlays, find ways to do this in user space. But there's also some interesting things happening, like AgentFS, which helps you build like an overlay, like our file system within SQLite, which is super cool. Like, so then you can inspect all the operations, revert, and so on. So this is also something I just read about and I want to dig deeper into. Okay, the third one and the final one and the most interesting one, like you see we went down a rabbit hole in this one, is preventing agents from actually destroying your cloud infrastructure, which is like the most scary thing. Like I wouldn't use Stakpak myself if this didn't work, because how can you rely on an agent to investigate something in the background using a CLI tool if you're not sure what it's going to do? So the most obvious solution as well here is give agents least privilege access. And there's a reason why this has been very hard to do for humans for years. Like, it's very hard to figure out beforehand what kind of access you would need before you need it. Because like if you're in the middle of investigating an incident and turns out you give yourself only read access and you can't revert stuff, then it's a bad thing. Like you need this access. But also because we have a lot of APIs. Like if you have a cloud native environment, you have a Kubernetes access, you have AWS access, GitHub access. So all these kind of, like it's very hard to manage these. And there are companies like built exclusively for managing access across different APIs. So this is very tough to do in practice. So we need to add security in depth. Like even if we get to do least privilege access and we want these agents to be autonomous and capable and be able to change cloud, how can we control this? The second solution, which is the most popular, is whitelisting, blacklisting commands and using hooks to help you prevent the agent from doing destructive things. Agents are super creative. Like I gave an earlier talk in the Cloud Native meetup in New York earlier this year, and we were forcing agents to generate 100% valid Terraform syntax. So it can only talk in Terraform, like it can't do anything else. And when we asked it to define itself or like to do something it was not supposed to be able to do by generating Terraform, it generated like a null resource that echoes a script in the file system and then runs the script. So they're really hacky, like they're super creative. So if you try blacklist or whitelist a command, it will just like find another way to do this, right? A Python script or download a third-party tool to do this and so on. They're very creative. So blacklisting, whitelisting, it doesn't work all the time. It doesn't give you the trust or the guarantees you need to be able to do this. A third solution is using code sandboxes. Like, who thinks this is a good solution? This is where our threat model is actually important. So remember, in the threat model, we were not trying to prevent, like in this case, we were trying to prevent the agent from destroying cloud resources over an API. The sandbox wouldn't prevent you from doing that. Like if you're running this via virtual machine and you give it an API key to the API, it will still be able to make API calls. So this coding sandbox is, at least how most people define it now, it's not enough. Because according to our threat model, the one we started with, we want to prevent it from making external calls to break things, not local file system changes, right? So this doesn't work. Like people think this would work, but it doesn't in practice. Another fourth-based solution is using AI-based detection. Who thinks this is a good option? Okay, I'm giving myself away. Okay, so here, for example, like for AI-based detection, people build specialized models that can detect with 99.999% accuracy that these commands are malicious or something is going wrong, so you can prevent it and so on. The issue here is of adversarial machine learning, which is the domain of finding a single example that would break a neural network and make it do the wrong thing. Either it's a language model and trick it into bypassing the guardrails, like trying to jailbreak ChatGPT, or a vision model like this one. So one of the oldest papers, I think it was in 2017, it resulted a neural net to mistake a hamster for a nipple. And this is not very malicious, but you get the idea. Like it's very easy to change a single pixel in the image to misclassify a command that is actually benign while it's malicious. And something more dangerous happened a couple of years later, in 2021, which you can 3D print actual objects that are adversarial examples to self-driving vehicles. This would attack like multi-sensor fusion networks where like they mix lidars with images with a lot of other sensors, and they, like researchers claimed for a long time that this makes the network more robust. But actually like 3D printing a small like white cube like that one would trick the self-driving vehicle or this model into like taking actions the attackers intended to design this model for it. So there'll always be an adversarial examples, at least theoretically, that would be able to do that. And the reason you would find it and how you'd find it is actually training another network to do this. So this is always bypassable. Like you can't trust this 100%. That's why most of the techniques we're using in this talk are all deterministic. So what did we end up doing? Here we ended up designing something we call Warden, which is a transparent proxy that like soaks in all the traffic from the agent and the MCP tools, and then applies policies in Cedar, like what Ray mentioned. And Cedar is like has some nice properties. We still haven't made use of all of them, but it's very simple to define a policy that like blocks all access in just like 30 lines of code, and would prevent your agent, its tools, or any of its dependencies from making destructive stuff on the network, because like intercepts it locally on your machine before it goes out of the network to do stuff. And you can see here, like this is the 30-line policy, and it even includes a rule that would allow the agent to call back to the Stakpak API, because this is where we do the inference. So this 30-line rule allows you to work on AWS without breaking anything. But let's try that. Like I promised you, we would try to break our production infrastructure, and let's do it. So nuke all the EC2s. Can you see this? Yeah, so let's try destroy everything. My team would not be very happy. Just do it. Yeah, okay. So even Claude thinks I'm crazy. Okay, yeah, so here, Warden intercepted the network request to destroy this instance and prevented it, and echoed back, okay, this is denied, this is not allowed. And this is done on the network layer. So regardless of what kind of tool you use, so you can use a CLI, custom Python script, Terraform, it doesn't matter. Like this is done on a lower layer, and you're sure this policy engine will work every single time. And it's, we call it network sandboxing. So there's still more things to do. Here, mainly the issue is the UX. Like I had to start Warden, like Stakpak with all its dependencies inside a single sandbox, but I want to scope this down. Like what if you can create a sandbox for a single command or like a single MCP server instead of everything? So then you can do a mix of safe operations and unsafe stuff. we want to allow people to turn it on and off mid-session. We want to be able to customize the policies on the fly, because like Cedar is really nice. Like if you have 2 or 3 versions of a policy, you can actually decide deterministically whether they're equivalent or not, or like subsets or not. So you can allow LLMs to write policies on the fly and have some guarantees about them. Finally, we want to try to turn this into a standard. So we want to collaborate with people building agents to improve this experience and have some sort of spec on how to build these kind of sandboxes and the different kinds of sandboxes. So this is an invitation, like come talk to me so we can try figure out like ways we can make this better, and like we can reuse this in other projects as well. So I'm trying out to a couple. I think there's an engineer at Anthropic that built a similar sandbox, but like in ways it's not a transparent proxy. Like it relies on CLI tools using like respecting system proxy settings, which are not possible in all HTTP clients. That's why we need a transparent proxy. There's also strong DM. They just like released something called Leash, which does exactly the same thing in terms of network sandboxing, but they also have some stuff going on and like intercepting system tool calls to file system changes as well. So we're trying to bring these efforts together by talking to these people and you, if you're interested, so we can reuse this stuff. Okay, so reach out to me on LinkedIn to discuss this or like hang around. And yeah, thank you all for having the patience.